In our previous video, we proved the Z property in neutral geometry, and it says that if we have a transversal to parallel line such that a pair of alternate interior angles are congruent, then the two lines must be parallel. So if you have alternate interior angles congruent, then you have to be parallel. So one of the questions you should be asking yourself pretty much any time you see a theorem in geometry or in any branch of mathematics is the converse true? Now, of course, in general, the converse is not necessarily true. If P implies Q, if P then Q, that's a statement. Then the converse is if Q then P, or Q implies P. And so that's definitely not an automatic thing. Okay, but some statements are if and only if statements, right? If P then Q, and if Q then P. So P if and only if Q. And so we want to examine that. So what would be the converse of this neutral geometry Z property? It would be, let's see, how will we state it? If you have a transversal to a pair of lines so that the two lines are parallel, then the alternate interior angles would have to be congruent. Is that true or is that false? Okay, and so let's investigate that in hyperbolic geometry. So I'll hide the Euclidean part, take a look at the hyperbolic, and we can look here by, I've drawn another transversal here, okay, and let the points of intersection be x2 and y2 with lines CD and EF. Now we know CD and EF are parallel. Just by inspection here we can see that they don't cross each other very clearly, and then also of course we proved it because they were constructed in such a way that they had this alternate interior angles up here at x. Well, as it turns out, all the red ones here are congruent and all the green ones are congruent over here. So we do have this one transversal where we get the alternate interiors are congruent. But look at this. Here the orange and purple are a pair of alternate interior angles, and look at the measures of them right here. Definitely a possibility, at least, of them being not congruent. And so guess what? The converse is actually false in hyperbolic geometry. So in hyperbolic geometry, just because we have a pair of parallel lines and a transversal does not mean that the alternate interior angles are congruent. In fact, we can go a little further than that. Even though they might have alternate interior angles congruent at one spot, that doesn't make them have alternate interior angles congruent for any transversal. So definitely a problem there. So the converse is false in neutral geometry. However, we will see that it is actually true in Euclidean geometry that if you get the alternate interiors congruent, then they're parallel, but also if they're parallel, then you get the alternate interiors congruent. It works both directions. So it is an if and only if in Euclidean geometry, but it only works in one direction in hyperbolic. And of course, as you might expect, somewhere along the line of proving that converse in the Euclidean case, you're going to use the fact that there is exactly one parallel through that point. Okay, whereas down here, given this particular transversal, there might be a parallel through x2 to this one, which has alternate interiors congruent, but there are others, and this is one of them that's not. Well, up here, since there's only one parallel, it is going to be the one where alternate interiors are congruent, and so we'll have to prove that as a theorem a little bit later on down the line. That'll probably be assigned as a project problem, presentation problem.